Betelgeuse, a big crimson, terrific large star located in the Orion constellation, fascinated humanity for hundreds of years with its severe crimson radiance and giant size. Astronomers have estimated that if Betelgeuse were to be placed at the center of our solar system, it would engulf all the planets up to Jupiter. This star's vastness signifies it is nearing the final phase in the life cycle of stars, like it preparing to culminate in a catastrophic explosion called a supernova. In recent years, however, Betelgeuse has exhibited extraordinarily uncommon behavior. Its luminosity surged by more than 50%, catapulting it from the 10th to the 7th brightest star in the night sky. This sudden flare of brightness led scientists to scramble for answers. Was this an early warning of its explosive death, or merely a brief blip in its existence cycle? The ramifications of this are great. If Betelgeuse were to go supernova, it could brighten the night sky to the extent that it would turn night into day, creating extraordinary scientific opportunities. A star's brightness is influenced by its size, temperature, and proximity to Earth. Betelgeuse, the radius more than 700 times that of the Sun, is relatively cooler, with surface temperatures around 3000 Kelvin. This gives it its signature red hue. Its size, combined with its low temperature, makes it a prime candidate for a supernova, making its recent behavior all the more exciting. In late 2019, Betelgeuse shocked astronomers yet again by dimming to just 40% of its usual brightness. This dramatic change, visible even without telescopes, triggered widespread observations and debate. Some speculated that dust may have obscured the star, while others considered internal processes at play. The possibility of an impending supernova became a key topic among experts. Using the Very Large Telescope VLT in Chile, astronomers managed to capture detailed images of Betelgeuse during its dimming phase. These pictures revealed that the star had taken on a noticeably lopsided appearance. Further analysis suggested that this dimming was likely caused by a massive surface ejection where Betelgeuse expelled an extraordinary amount of material into space. This unprecedented event altered the star's appearance and disrupted its pulsation cycle. The event was akin to a volcanic eruption, only on a cosmic scale, as Betelgeuse ejected over 400 billion tons of material, far more than typical solar events. This upheaval not only changed the star's look, but also shortened its expansion period from 400 days to just 200. Such radical changes indicated that Betelgeuse is becoming increasingly unstable, sparking further questions. How much longer can it maintain its current state? Because of its volatile behavior, astronomers have ramped up their monitoring efforts, eagerly attempting to find signs of its imminent collapse. When a massive star like Betelgeuse exhausts its nuclear fuel, its core collapses under its own gravity, triggering a supernova. This colossal explosion releases an enormous amount of energy, blasting the star's outer layers into space and creating a staggering light show visible even during daylight. If Betelgeuse explodes, the initial sign might be a burst of neutrinos, tiny subatomic particles that travel faster than light and can escape from the star. These neutrinos could reach Earth hours before the light from the explosion itself. Once the light arrives, Betelgeuse could shine brighter than the full moon, casting eerie shadows and illuminating the night sky for weeks. A supernova of this scale would present an exceptional opportunity for scientists to observe stellar death in real time. By studying the emitted light, heat, and radiation, researchers could gather precious information about stellar evolution, nuclear physics, and the formation of elements essential for life. To understand Betelgeuse's unusual behavior, scientists are using advanced simulations to model the star's interior. These digital models include data from telescopes like the James Webb Space Telescope, JWST, and the VLT, allowing researchers to explore the mechanisms behind Betelgeuse's instability. These simulations have shown that a massive gas bubble likely formed deep within the star, triggering and altering its pulsation rhythm. Observations from the JWST have provided a clearer view of the material ejected by Betelgeuse, revealing intricate structures of gas and dust surrounding the star. These findings suggest that Betelgeuse may be nearing the final stages of its life cycle, offering an unprecedented window into the life of massive stars. While scientists predict that Betelgeuse could go supernova within the next 10,000 to 100,000 years, its erratic behavior suggests the timeline could be much shorter. The astronomical community is racing to capture every detail of this cosmic spectacle before it reaches its dramatic climax, ensuring humanity doesn't miss this rare event. In late 2023, the JWST, with its unmatched observational capabilities, focused on Betelgeuse and uncovered startling new phenomena. Scientists discovered that the star, already in a state of instability due to its massive surface mass ejection, had undergone a rapid internal collapse. This collapse was indicated by significant changes in its core dynamics, which altered the flow of nuclear fusion reactions. Astronomers observed dramatic fluctuations in Anika. If you're using like a scanner app and it's like, we're gonna die, like Pricito as a brace clad like you're gonna die. Like, look at this. And we all know, I've been exploring, and we saw it, and we all love. We have a love of a clade slash pre-claging a slash aways. A slad ascraze me with slash pre-cade slash calajav at weekend die size. Caniseed, quart quite decide quatus, seaweed will with concuse y quidoe duanoe widowe to kini to see we so first succumb with sect to kagay to see to iso week. Betelgeuse's expansion cycles before the collapse, with the star's surface expanding and contracting steadily over 400 days. Afterward, this rhythm was suddenly shortened to just 200 days, signaling a major disruption in the star's internal structure. These irregularities served as a cosmic heartbeat, signaling that Betelgeuse might be approaching the end of its life as a red supergiant. Simulations conducted by astrophysicists revealed that the core of the giant star is becoming increasingly unstable as it fuses heavier elements. When stars reach this stage, they begin producing a runa process that marks the final phase before collapse. Unlike other elements, iron does not release energy when fused, leading to a buildup of mass that eventually causes the core to collapse. Betelgeuse's recent behavior has sparked intense debate among astronomers regarding the timeline for its supernova. While some argue that the explosion could occur within the next few centuries, others believe it may still be hundreds of years away. What is clear, however, is that Betelgeuse's time as a red supergiant is drawing to a close. One of the key signs that a supernova is imminent is a surge in neutrino activity, tiny subatomic particles that escape from the star's core moments before it collapses. Scientists are closely monitoring Betelgeuse for any unexpected spikes in neutrino activity, and instruments around the world are on high alert to detect this fleeting signal, which could provide humanity with its first real-time warning of an approaching supernova. A celestial event seen even during the day, scientists assure us that it poses no threat to Earth. However, its brightness could rival that of the full moon, casting ordinary shadows and illuminating the night sky for weeks. This event will not only captivate stargazers, but also provide an unprecedented opportunity for researchers to observe stellar death in real time. The story of Betelgeuse reminds us that the universe is still filled with mysteries waiting to be discovered. This significant star, which has mesmerized humanity for centuries, continues to challenge our understanding of stellar evolution and cosmic dynamics. As Betelgeuse surprises us with its dimming mass ejections and unpredictable behavior, it serves as a reminder of how much we still have to learn, its potential to go. Supernova gives scientists an outstanding opportunity to examine the life cycle of massive stars firsthand. Understanding these processes goes beyond unraveling the fate of one star. It's about unlocking the mechanisms that form galaxies, seed the universe with critical elements, and even make life possible. This knowledge expands our understanding of the universe's history, and our place within it. The tools we use to study Betelgeuse, from ground-based observatories like the Very Large Telescope to cutting-edge instruments like the James Webb Space Telescope, have opened new windows into the cosmos that past generations could only dream of. These technologies allow us to run simulations, study stellar dynamics, and peer billions of years into the past, all to better understand the very fabric of reality. For scientists like Neil deGrasse Tyson, discoveries like these spark excitement and urgency. They push the boundaries of human knowledge and challenge us to keep exploring the cosmos. The next time you look up at the Orion Belt, remember that one of those points of light tells the tale of a star nearing its fate. What do you think will happen to Betelgeuse? Are we witnessing the final moments of a star about to explode? Or is it simply another phase in its mysterious life cycle? Share your thoughts and join the conversation about one of the most fascinating stars in the universe. Don't forget to like, subscribe, and turn on notifications for more cosmic stories that will leave you in awe. Until next time, keep your eyes on the skies. As we continue to observe Betelgeuse and its behavior, it becomes clear that this star is not just a fleeting spectacle in the night sky. Its unusual activity is offering astronomers rare opportunities to study the complex processes that govern the evolution of massive stars. Every shift in brightness, every surface mass ejection, and each surprising change in pulsation patterns brings us closer to understanding the mechanics of stellar life cycles. One of the most captivating aspects of Betelgeuse's evolution is the fact that it's in a relatively rare stage of its life cycle. As a red supergiant, Betelgeuse is nearing the end of its existence. However, its path to supernova is not as straightforward as it might seem. The precise causes of the irregularities in its behavior are still being debated by scientists. While the surface mass ejection is one of the most dramatic events observed so far, it may be just the beginning of a more complex series of changes that lead to the star's eventual collapse. What's equally fascinating is that Betelgeuse's supernova could offer answers to some of the most fundamental questions in astrophysics. The explosive death of a star like Betelgeuse holds the potential to reveal secrets about the nature of dark matter, the expansion of the universe, and the intricate processes that lead to the formation of new stars and planets. These revelations could help scientists refine current models of the cosmos and gain a deeper understanding of how the universe has evolved over billions of years. The research being conducted on Betelgeuse is part of a broader effort by the global astronomical community to understand the life cycles of massive stars. By studying stars like Betelgeuse, scientists can learn about the end stages of stellar evolution, which are notoriously difficult to observe in real time. Most stars die in ways that are incredibly distant and hard to witness. So when a star like Betelgeuse begins to show signs of its final explosion, it provides a rare opportunity to study this cosmic process up close. One of the questions that remains unresolved is how long Betelgeuse has before it eventually reaches the supernova stage. The timeline for the star's death is still uncertain, and scientists are constantly adjusting their predictions based on new data. Some astronomers believe that Betelgeuse could explode sooner than expected, while others think it might take thousands of years before the supernova occurs. Regardless of when it happens, the excitement surrounding the star's eventual explosion remains palpable. For now, researchers continue to monitor Betelgeuse closely, using an array of state-of-the-art instruments to capture every bit of data they can from ground-based observatories like the VLT to space telescopes like the JWST. Scientists are using the latest technology to peer into the depths of this giant star. The data they gather will help refine our understanding of stellar evolution and offer insights into the forces that drive the universe itself. As Betelgeuse's story unfolds, serves as a powerful reminder of the vastness and complexity of the cosmos. The universe is full of stars that undergo great transformations, but few offer such a clear window into the final stages of a star's life as Betelgeuse does. Its imminent supernova may be a major event, one that could help scientists answer some of the most profound questions about the nature of stars, galaxies, and the universe as a whole. While we don't yet know exactly when Betelgeuse will explode, one thing is certain. Its eventual death will be a momentous event in the study of stellar evolution. For astronomers and scientists around the world, it's an event that promises endless opportunities for discovery and progress in our understanding of the cosmos. And for the rest of us, it will be a reminder of the extraordinary beauty and mystery of the universe we call home.